All right, so previously, on a project from a long time ago, we made some rectangle approximations to this triangle. So what do you think these represent? What are we doing to our triangle, and what about these shapes help us find the area?
So we're using rectangles to get better and better approximations for our triangle.
Okay.
So like here we're using 5 rectangles, and then it's 13 or 14.
Okay.
And it's a bunch, and then just get really, really small, and you just get a better and better approximation to what the triangle is. Yeah, what the triangle is.
Okay. And all right, so let me draw this out now. So when you have a general curve, and we'll do a parabola next. Here's y equals x, going from 0 to 2.
Mm-hmm.
And you might say, well, I don't know how to find the volume of a general shape, or the area, of a general shape, but I do know how to find the area of rectangles. So I'll just chop this up and approximate it by some number of rectangles. For now, we're going to assume these rectangles have all the same width. Okay?
Alright.
Alright, so here I've got 1, 2, 3, 4, 5 rectangles. And so how wide are these rectangles?
2/5.
Okay. So this is the point 2/5. This is the point 4/5, 6/5, 8/5, and then 10/5.
Mm-hmm.
Okay. So how tall is this rectangle here? This one?
2/5 tall.
How tall is this one?
4/5 tall.
This one?
6/5 tall, and then 8/5, and then 2.
Yeah. So my drawing's not perfect. It probably even looks more exciting in red. But if we were going to do this as an approximation, we would say the area of each one of these rectangles. So the area of the triangle is approximately the sum of the rectangles.
Mm-hmm.
Well, how wide is this first rectangle?
2/5.
So 2/5 wide times how tall?
2/5.
2/5. And then plus the next one is 2/5 wide times
4/5 tall.
4/5. And then I could go plus dot 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 up to the last one, which is 2/5 wide times
2 tall.
2 tall. And maybe I could factor 2/5 out of everything and have the sum going from I equals 1 to 5 of something over 5. And what would that something be? What is the height of my rectangles as a function of I?
2i.
2i. Or in other words, I would have the sum of 2/5 times 2/5 times I. Right?
Mm-hmm.
Now what if I used n rectangles instead? How would this change?
Well, you need to do 2 over n instead of 5.
Okay.
So you basically in this formula you replace 5 with n.
Okay. So I would be finding the sum I equals 1 to n of 2/5 times the whole sum.
It'd be 2 over n.
I over n.
It'll be 2 over n.
2 over n, sorry. Yeah, you're right. 2 over n times 2i over n, which I can simplify to be the sum of just I on the inside, and I get 4 over n squared. And what's the sum of I from I equals 1 to n?
I equals 1 to n is n times, or n times n plus 1 over 2.
N times n plus 1 over 2. So then I would get 4 over n squared times
the n times n plus 1 over 2.
n times n plus 1 over 2. And what does this simplify to be?
So we can cancel the 2,
Uh-huh.
and we can cancel an n.
Alright.
So we get 2n plus, so 2 times n plus 1 over 2, or over n.
Yeah. And how about as I start using a larger and larger number of rectangles, what do I get?
So then it's basically 2 times n over n, so basically 2.
Basically 2. This goes to 2 as n gets larger. By the way, it's always larger than 2 in this case. Why? Why is that? Why does that make sense?
Because you've got little bits of rectangles that go over it instead of.
There you go. Now that's just kind of a silly thing, right? Because why would we find the area of a triangle that way?
Yeah.
But now we'll do the area under y equals x squared.